Hello friends, today I'm going to solve LeetCode problem number 472, concatenated words. So in this problem we are given an array of strings, words which doesn't have any duplicates, and we need to return all the words that have been formed by concatenating the words in the list. And for a word to be concatenated, it should be entirely formed by using any of the two other words in the given array. Now let's look at this example here. I have copied this example here, and let's start with this first word in this example. So what do we have here is cat, right? So we need to actually check if this entire word is comprised of any at least two words, at least. So for that we need to break this word into substring, right? So what do? We start iterating over the characters, each of the characters starting from the first, and then we break the substring into two halves. First half is C and the remaining half, and then we check, is the first half, that is the character C, present in this words array? Well, it's not present in the words array, right? So what we do is now we increase the length of our first half, and now our first half character substring is equals to CA, and then we again check, is it in this array? It's again not in this array, right? So in the next iteration what we do is we check for the, we increase our window again and we check for the substring CAT, and is it in this array? Yes, it is available in this array, right? So what we do is we increment the count of our number of substrings by 1. So initially it's initialized to 0, and then we increment it by 1, so now the value is equals to 1. And also now what we do is since we have created a substring with this character, what we do is now the remaining word, the remaining character here, what's the remaining character? Apart from these three characters, it's 0, right? The length becomes equals to 0. So now the value of n is equals to 1 and the length is equals to 0. So since the value is equals to 1, we are actually not going to add this to our result array, because it should be comprised of at least two sub strings that are present in this array, but it is only composed of one string, that is it itself, right? Now let's move to another example, which is cats. Here next word is cats. We have already found this word in this array, right? So we already know that cat exists in this array, so the count for n is equals to 1 now, and the remaining length of our string is equals to 1, which is this string. Now we calculate for the value for this substring, as is this substring present in this array? Well, it is not present in this array. So now we do not have any remaining characters in this string, right? So far we only found one character, and it's not entirely composed of the substrings in this array. So what we do is we just return false. We do not do anything. Next, moving on to our another example. So our another example is cats. Okay, let me make a hypothetical example by myself so that I can explain you a case here. So an example is cat dog, right? Now we start from the very beginning character as we do it for the cat. So we look for the character C. It's not in this array, actually character, not actually character C, but the substring C. Then we look for CA. It's not in this array. Again we look for CAT. Now we found our substring cat in this array, so the value of n is equals to 1. And then we move on to the next substring. So we create a substring of only character D, and we look at this array and it's not present. So now our next substring is DOZ. So we search for DO, initially only DO. So DO is not present, and we look for the substring DOG, and DOG is present here, right? So what we do is now this string is also present, so we increment the value of n by 1. So now value of n is equals to 2, and the remaining substrings, we do not have any remaining characters in this word, like the length is equals to 0, which means that we have formed, we know that the whole this whole string is entirely formed by at least two strings in this character, two words in this array, right? So what we do is we push this string to our resulting array. Now let's look at this example here where we have cat's dog. So we have an example, cat's dog. So it's just similar to this example, so I'm not going to explain this example but rather this example here. So what we do is we start from C and again move on to CAT, and we know that CAT is present in this array, right? So what we do is we increment our count by 1. Now we look for character S, it's not present, and we look for SD, the substring is not present, SDO and SDOG, and we do not found any substring. So what we do is now we return back to our character S, and here what we are actually doing is performing a DFS operation. So since we did not find anything, our value of I was here equals to 0 because we concatenate, we take this substring. So looking at this as a starting index, it was 0. Now our index will be equals to, we take okay, so we return back, and what we do is now we take, initially we took only CAT as our substring, right? Now we'll take CAT as our substring, and we know that cats exist in this array. So initially we will have the same value here updated to value 1, and then we keep on looking for the value dog. So we saw that SDOG doesn't exist in this array. So what we do is we return back to the substring that we found, that is cat, and then we try to extend the value of this substring. So what we do is now rather than looking for cat, now we look for cats, that is adding one extra character to it, and we look for cats, and we know that cats is present in this array. So this becomes our another substring. So our value of n is equals to 1, and then we look for the next substring starting from length equals to 0. So we know that D is not present, so we look for DO, and then we look for DOG, and then we finally find our next substring in this array, and then we increment our value by 1. And if there is another, like if we still have these cats for this example, if we have this one, then we are again going to look for this whole cat, and we know this cat is present in this array, so we increase this value by 1. Even though the value of n is greater than 1, the whole we have not yet found the whole entire word in this array, right? We still have the character s remaining, and the character s is not found in this array. So what we do is we return back, and now our last substring, as we did for the cat, we extended it by 1 character. That is what we'll do for cat. Now we add the character s, and then we search for this whole character in this array. What if we had an extra e here, and let's suppose we have a string CATS e in this array? Then we would actually do the same thing again. So we will take this whole string and then see that this string is present here, and then finally return our result by concatenating these to our result array. So now that you know how this is done, let's try to code it. So we will actually need to convert our words to a set, so that it's easy for us to look for the words if it is present in this words array or not. Now we have created our set, and let's create our result array. All right, now let's start with our DFS function. So what do we need in our DFS function? Let's look back here. So we start from a given word, and what we do is we loop over. We start from the first character and we keep on moving as long as we have not found that character, the string. Once we have found the string, what we do is we remove this whole string from the word. Now our new word becomes this word, and then again we keep on looking for this substring in that word, and once we have found that substring, we remove that substring and we keep on looking for the next word. So we need a word, and we also need to keep the count of the substrings in the word, so that if we have found n number of substrings which is greater than or equals to 2, and the word at the end remaining is equals to empty string, then we are going to push it to our array, to our result array. So we'll need the word and the value of n. So word comma n, which is the number of substrings. So the base case is if n is greater than equals to 2, and the word should also be of length 0. That means the entire word is composed of the substrings. That is when we will push to our result. Okay, not push, but actually I'm going to return the value true, because the word here is already an empty word, and we don't want to return and push an empty word. We need to push the original word, right? So now starting from the index I for each of the word, so what we do is now we take the substring, and okay, so substring 0, I equals to 0 would be empty substring. So we take the substring and then we check if the substring is present in the set. If it is present in the set, then what do is we increment, we call our DFS function, right? So we remove the substring from our word, so I'll slice it, and then we increase the number of count by 1 if everything goes fine. So if the value is returned is true, that is if we have found our value, then we are going to return the value true, right? If we have found it already, then we are just going to return it, because we want to break out of the loop. If we have not found anything, that is the substring is not entirely composed. For example, so far in the case of cat, we found that n was equals to 3, but we still had the character s that was not found, right? So in that case we would return false, and then when we return false, the DFS here is return false, right? So what we do now is we actually increment the value of I, and that would increase our substring. So now our substring would be cats instead of cat, and then since we found our substring cats in the array, and what we do is we slice our word at index I, and at that point of time where we have reached this value, where we have concatenated, when we have found these cats, we have no more a word, any character remaining in the word, right? So after we slice it, so we slice it, and the word here is empty string, and the value of n is also greater than or equals to 2, so it returns true. And then once it returns true, we just want to break out of the loop because we don't want any further manipulations. And then we are going to do that for each of the word in the words array, right? So for each of the word in the words array, if the DFS function called on the word is true, then we are going to push to our result the original word, and then finally we are going to return our result. Now let's run our code. Okay, substring function. All right, something went wrong here. Okay, so we need to do it as long as I is equals to the length of the word, because we always in case of substring we always exclude the ith index. That is we won't be considering if in case of cat, cats, dog, cats, if in this case our remaining substring is this much, right? Our remaining word would be this much once we have found cats and dogs. So in that case the length is equals to 4, right? But if our value of I was only less than the length, then the value of I, maximum value, would be equals to 3, and 3 would be 0, 1, 2, 3. So the index 3 would actually be excluded, so we will only get the substring cat, and s will never be included in the cats. If we include, if the value of I is equals to 4, that is only when it includes the substring includes the value from 0 to I minus 1, that is 0 to 3 will be included. So 0, 1, 2 and 3, these whole characters will be included in our substring. So that is what we need. Cool, let's submit our solution.